Have you ever wondered why you can't hear any sound in space? Is it because of the vacuum, the absence of air, or something else? Well, let's delve into the science of sound to understand this. Sound is a type of energy that is created when something vibrates. These vibrations move through mediums like air, water, or solids, causing the particles in these mediums to vibrate too, and voila, we hear sound. But here's the catch. Space as we know it is a vacuum. It's incredibly empty. This vast emptiness means there's no air, water, or any other medium for sound vibrations to travel through. So, no matter how loud an explosion or how epic a celestial choir might be, we wouldn't hear a peep. It's like trying to listen to a concert from inside a vacuum-sealed jar. So, the next time you watch a sci-fi movie with all those dramatic space explosions, remember, in reality, space is a silent place. Black holes are often depicted as giant, menacing vacuums sucking everything into their abyss. But is that what they really are? Let's dive into the fascinating world of black holes. First off, contrary to popular belief, black holes aren't cosmic vacuum cleaners. They don't go around space, gobbling up planets, stars, and unfortunate spacecraft that happen to be passing by. Black holes exert gravitational pull just like any other body in space. The strength of this pull depends on both the mass of the black hole and the distance from it. It's only when an object gets very close to a black hole, within what's known as the event horizon, that the gravitational pull becomes incredibly strong. So if you were to float by a black hole at a safe distance, you wouldn't suddenly find yourself yanked off course and sucked in. Your journey through the cosmos would continue uninterrupted, much to your relief, I'm sure. Now, about their appearance. Despite their name, black holes aren't actually black. In fact, they're not visible at all. Their gravitational pull is so intense that even light can't escape. This means that black holes are invisible to the naked eye. Any images or representations you've seen are likely artistic interpretations or the result of special imaging techniques. In reality, black holes aren't the monstrous vacuums we often portray them to be, nor are they visible as black entities in space. Instead, they are invisible yet incredibly powerful phenomena, fascinating us with their mysterious and elusive nature. Astronauts floating around in space stations give us the idea of zero gravity in space. But is there really no gravity in space? Well, let's burst that bubble. Gravity, my friends, exists everywhere in space. Yes, you heard it right. Everywhere. It's the force that keeps the planets in our solar system orbiting around the sun. It's the very force that keeps our feet firmly planted on the ground. It's all around us, and it doesn't magically disappear once you leave Earth's atmosphere. But here's the twist. The strength of gravity gets weaker as objects get further from the source. So the farther you are from Earth, the weaker its gravitational pull. But make no mistake, it never hits absolute zero. Now hold on to your seats, because here comes the next part. You see, what astronauts experience in space stations isn't zero gravity, but a constant state of freefall. Yes, freefall. Imagine yourself in a lift. If the cable snaps, you and the lift fall at the same rate. For a fleeting moment, you'll feel weightless, even though gravity is very much at work. That's exactly what's happening to astronauts. They're falling towards Earth, but also moving forward fast enough to keep missing it. This creates the illusion of zero gravity. So space isn't really a place of zero gravity. Rather, it's a place of constant free fall. Today we've explored and debunked some common myths about space. We've ventured into the silent expanse of the cosmos, realizing that the lack of a medium for sound to travel results in an eerily quiet universe. We've peered into the enigmatic depths of black holes, debunking the myth of these celestial bodies as giant cosmic vacuums. Instead, we've discovered their true nature. They are invisible due to their extraordinary gravitational pull that lets nothing, not even light, escape their grasp. And we've floated in the realm of what is often misnamed zero gravity. In reality, we are constantly in a state of freefall while in space, giving us the illusion of weightlessness. So it's not that gravity doesn't exist in space, it's just experienced differently. Remember, space continues to be a place of mystery and wonder, with much more to discover and understand. Until next time, keep looking up.